Hello judges, I am Yash and we are presenting TuskOS for the Walrus track of the SUI Overflow 2026 hackathon. The problem we are solving is critical. Today's AI agents are fundamentally stateless and isolated. If we want autonomous swarms to scale, they need shared memory. But relying on centralized databases to store AI context is a massive compliance liability. We need agentic memory to be verifiable, persistent, and entirely sovereign. To solve this, we built a two-stage architecture. The foundation is our open-source Tusk-Memory SDK, a developer primitive that bridges AI state directly to Walrus. Sitting on top of it is our application layer.
Let us proceed with the demo. The first step is to create a new board. Select a board name and the defined topic for which we are going to perform our analysis. Here you can view our topic. It is about a lending and borrowing protocol on SUI, where users collateralize SUI to borrow a synthetic stablecoin pegged to USD. I'll copy this, then finally paste it in our board, and I'll write the board name to be SUI stablecoin drawdown and click on create board. The next step is to select Risk Simulation in the Swarm Engine mode. Finally, we will click on Run Agents. As you can see it live, we are actually initiating a deterministic reasoning loop. A red agent is aggressively finding exploits and the blue team is dynamically patching them. Once they reach a mathematically verified consensus, the volatile session memory is purged. Here you can see that they have reached a consensus at the end of the chat. And this is the entire chat. Now, the next step is to seal our journal. We'll click on this option, approve the transaction request, and finally, as you can see, that our agentic chat has been sealed and stored locally. Now, in order to store it on blockchain, we'll have to archive it as well. Simply clicking on archive does it. Here, as you can see that as chat has finally been archived and is now stored on chain. We can view the verifiable artifact here. Here is the entire chat in encrypted form stored on Walrus. We can see our archived chats here in the archived chat section. Here, this is the chat we just archived.
Here I have selected my chat and then I can unseal the chat using my signature from my wallet. Here I have unsealed my chat and I can view it as well. The next step is to share the chat. As we know that agents are generally stateless and isolated, that is, agentic memory cannot be shared across different agents or across different apps. Memory is only useful if it can be shared. I want to pass this exact risk matrix to another analyst. In a Web2 app, we would have to flip a database flag. In TuskOS, I use a zero-class cryptographic lock. Let us finally share this chat. I will click on the Share Chat button and I will paste the recipient's wallet address. Then I will click on Grant Access. Finally, I will grant the recipient access to view this chat. As we can see that the transaction has been confirmed on-chain and we even have the transaction signature. The recipient can now discover this journal in the shared memory inbox. Now, finally, I will switch my account and go to the recipient's account. I will go under the shared memory section and as we can see, I have received this chat. I will unseal the chat, sign it from my own wallet. As we can see, I finally entered the password in my wallet and I have unsealed the shared chat. Next step, I can click on import to board and import this chat on my live working board, even though I'm on another account. Finally, the importing is done. It took a while, but as you can see, the chat has finally been imported. And now, even if I want to change something, or if I want to edit, or I want my agents to pursue this chat further, I can do all of it. Finally, let us move on to the final step. I've switched back to my original account. For the final test, let's prove the true data sovereignty.
I've added a beta NewDB feature here. This is not a production feature and present here just for the demo purposes. When I click on this feature, as you can see that my data is deleted from the MongoDB, which is actually used to ensure fast queries whenever I'm archiving the reports. If I click on OK and give my wallet signature, as you can see, my DB has been nuked. As a proof that this feature is not hard-coded, we can see the logs in our terminal. Also, as you can view in the MongoDB entries, there are only presently two entries after the deletion. Hence, the database is dropped and the UI has collapsed in the archived report section. In any traditional application, the agent's memory is permanently dead. However, in TuskOS, we can rebuild our database whenever I click on Rebuild from Blockchain. The application instantly reconstitutes our entire UI by streaming raw logs straight from Memwall and the data blobs from Walrus. The server outage is completely irrelevant. As we can see, the sync is now finally completed and we can also open this chart now. Furthermore, on refreshing my MongoDB database, I can see that the entries have again increased to 4. That is, the data was restored from blockchain and it was also populated into the MongoDB. Hence, there is no Web2 point of failure here, and even if the MongoDB, which is used for indexing and fastware responses, collapses, we can still fetch the original data back from Walrus and Memwall and actually repopulate our database. As a final step, I want to show you the Tusk-Memory SDK, which we did not build for ourselves, but for everyone. Everything you just saw is powered by our open source SDK and is live on NPM right now. Any developer can add verifiable, sovereign Walrus memory to their agents today in just a 3 to 4 line of code. The future of agentic web is sovereign. I hope you liked our presentation and our entire two-fold architecture.